All right, guys, now let's talk about the objective RC3, which is some more linear functions, equations, and inequalities, but now we're writing and solving them, okay? So a couple things, some keywords to notice in this objective is the word domain and range, okay? We need to make sure we associate domain is your x values, okay? And your range are your y values. Now, a lot of times they're going to give you a graph and ask you to come up with the domain and range as an inequality. There's some parts to the graph you need to recognize. So when domain, we have to focus on the values on the x-axis. And let me get my font here. So a couple things. If it's a closed dot, this is when we're going to have the line underneath the inequality right here. So when we read the domain, we read left to right, okay? Left to right. So we find this point, we look up on the x-axis, that's at a -5. So we start from the left side, go to the right side. -5 is less than or equal to x, and then this is an open dot, so we don't have the line underneath it, and it's at 6, okay? Now range is when we go bottom to top or low to high, okay? The low, this is a curve here, the lowest it gets is here, but then I have to look at the y value, and it's at a -6. And since this curve is solid, that's why it's going to include that point. And the highest it gets is here, and I look on the y-axis is at 2. Again, it's solid curve, so we have to include that point, so we have to have the line underneath. Now, a couple things. Anytime you see double arrows right here, anytime we have double arrows, and I'm just going to write that. If I see double arrows, okay, that means your range and domain, oh, my pen stopped working, sorry, it's going to be all real numbers. Your range and domain will be all real numbers. So we can have the symbol for that, okay? If they're going to show an inequality, let me extend this page just a little bit, that would be, remember, if it keeps going, that's a negative infinity, which remember, we don't have to include it, to positive infinity, or negative infinity to positive infinity, okay? So anytime we see double arrow. So now for this, the parabola, remember, we have to find its lowest or highest point, okay? This has a minimum, oops, I'm gonna fix that, a minimum here at 3, and then it's pointing up. So this is y is greater than or equal to -3, okay? Or they might write it in words. So make sure you know your symbols, all right? The next thing we're going to get into in this objective is solving equations. Remember, this is now solving, and this section is going to require you to solve and write linear equations, functions, inequalities. So I'm going to talk about solving by pencil and paper, and then I'm also going to show you a way to check with your graphing calculator. So to solve this, you have to remember anytime I see parentheses or a number outside the parentheses to distribute, okay? So basically this is saying like a third of 15 would be 5x, okay, plus 45 is less than 6x plus 54, okay? Now we're solving for x. We want to get the x on the left side. So I'm gonna, because the inequality will show me which way to go to graph it. So I'm gonna do -6x, okay? So -x is plus 45 is less than 54, okay? And then we're gonna subtract the 45, okay? And I'm gonna come up here. We have a -x is less than 9, okay? Now we can't keep it a negative, so this one we divide, oops, sorry. We divide by -1, and then remember, anytime we multiply or divide by negative, exactly, you have to flip that symbol. So what we need to do now is, did that right? Yeah. Obviously our inequality doesn't go to 9, so I'm just gonna go here, put a 9. It's open and it's pointing to the right, okay? Now, the way you can use your calculator to get this answer is what you have to do is you have to make the left side 1, put this in y1, and then the right side, put it and y2. Okay, so you go to your calculator, and I get my calculator here. It's gonna take a while. Hold on, let me get it on. Okay, so you get the left side in the inequality in the equation, and then you get the right side of the inequality in the equation. You want to graph it, okay, and then you want to find the intersection. So to do that, remember you have to do second, trace, and then you hit 5, enter 3 times. So we get the intersection here at a -9. Okay, so let me go back. Which reminds me, there we go. Good thing we did that. I forgot my sign right here because we're dividing by a -1. So this should have been a -9. Sorry about that. And then look over here, -9. It's an open circle, but it's pointing to the right because the inequality right here is pointing to the right. Okay. So yeah, that's a way to check it. Good thing I did that. We're going to talk about that some more on the calculator tricks at the end. So from here, we have to know our equations of lines. Okay. Parallel lines, we have to remember have the same slope, but a different y-intercept. Okay. Perpendicular lines have opposite, I'm going to abbreviate that, reciprocal slopes. I'm going to abbreviate that as well. This is when we have to flip. Oops, dang, I cannot write today, sorry. You have to flip the number and switch sign. Switch the sign. Flip and switch, all right? Horizontal, oh, make sure we have this memorized. They do this a lot. It's always y equals a number. Okay, so an example, y equals 3 or y equals -5. Those are horizontal lines. You have to remember the slope, it will always equal 0, and horizontal lines are parallel to the x-axis, okay, on the coordinate plane. Then we have vertical lines. This is when the slope is undefined, okay, and they are perpendicular to the x-axis. They like to talk about that characteristic a lot. And so things that we did, I'm going to just erase this. Remember, to help us remember horizontal, we did OI, and then we had VUX, okay? You can have that acronym to help you remember. And so this is when we're going to get into writing the equation of the line. So to do this, we have to want to first do the point slope form, because this is the point, and in the equation I can find the slope. Okay, so I'm just going to write, always do first point slope form. That's the form when we have y minus y1 equals m parentheses x minus x1. Okay, so I'm going to first put this in slope intercept form so I can see the slope. I just have to minus the 3x to do that. Okay, so this y, now I see my slope is a -3. Because I want to use this, that's the slope, and I use the point, this is my x1 and my y1, into the form. So when I plug it in, this would be y minus 6, that's the y1, equals the -3, that's the m, parentheses x minus 3. And then to solve it for y, okay, because this is, write the equation, this is right here in slope-intercept form, we just have to distribute and then add or subtract. So we have y minus 6 equals -3x plus 9. And now we just have to add the 6. I should have written that in black. Okay, and so we have y equals -3x plus 15. All right, so what I want you to do is try the number 24, but this one is asking for the perpendicular slope versus this one was the parallel slope. Okay, so let's try 24. I'm gonna just pause and hopefully to see your slope, you added the 3 first to get that y by itself. Okay, hopefully now you see the slope. We can just switch these around if you need to. Your slope is the 2. Okay, so for perpendicular, what do we have to do with that number? Exactly, let's see if we can get to it. All right, so if you worked out, you should have got y equals a negative 1/2 x plus 5. Okay, if you want to pause and look at the steps so you have a better understanding, you're more than welcome to. All right, so here's a good STAAR-like question to help you see if you can come up with the equation. The key words here is x-intercept of 4. So that, you think of that as an order pair, 4, 0. And a y-intercept of -2. So that's 0, -2. Which function represents this relationship? So I'm going to let you try this different ways. We could do this. We can try to write the equation. We can try to plug in to see which one works out. Okay. But in order to use your calculator, you have to solve for y. So unless you're plugging in the values in, you're gonna, if you want to use your calculator, you're gonna have to solve for y. So this would like be minus x. So this would be 2y equals negative x plus 4, and then you have to divide by 2. By 2. So y equals negative 1/2 x plus 2. Okay. So I'm gonna let you try, and then we're gonna see which one is our correct answer. We should have got B on here. You can see y-intercept -2. There it is. And then I'll plug in my 0 here. Sorry, 0 here. That would work as well. Check your answer. I think we were doing this here. Okay. And so on our next thing, I have to know direct variation. A couple things for direct variation. It has to go through the origin. Okay. It's always going to be a straight line. Y varies directly to x. So y is on top and x is on bottom. Your k, this is just the form of the equation, and your k would represent the slope. So an example here says y varies directly as x, and y is 28. So y varies directly as x looks like this. Okay. So we have 28. Sorry, that's when x is 7. Find y. So we need to find y when x is 15. So what you do is you want to set up a proportion, and we want to cross multiply, or we look for the pattern, like, see, this is going to reduce 28 over 7 to 4. So I'm going to do the opposite here. But if you do cross multiplication, it works too. So this is 7y equals, some of you might have saw the shortcut. Was that 120? Yeah, that's not 120. It is 420, sorry. And then we're dividing by 7. So y equals 60. This is what I'm saying. So if I dividing by 4, then I could just do the opposite times 4, and that would have gave me 60 as well. Okay. So from that, then we're going to systems. So there's 3 ways to solve. Okay. Know when's the best method to be used. If you have both y equals, then you should use graphing. Like, you should go to your calculator. I would put this in for y equals here. And then you have to remember, do second, trace, and then pick number 5, enter 3 times. So if I look at the calculator here, we go to y equals, I need to clear these out. We're putting in the 2 equations that were given, which was x plus 4 and 2x, or negative 2x minus 2. The graph, second trace, 5, enter 3 times. So our solution is negative 2, 2. Okay. Now, use substitution method when one equation has a variable isolated. You have either y equals or x equals. So here I have an x equals, so I'm going to substitute what it equals, so 3y minus 4 in place of x in the other equation. This is when you have to use parentheses. So we have 4 parentheses 3 minus 4, close the parentheses, minus 5y equals 5. And we're going to solve for y. Try that. Alright, should solve for y and get 3. So don't forget to plug it back into the original equation. 3 times 3 is 9, minus 4 will give me 5. So the answer is 5, comma 3. Now the third way is to use elimination. This is when the variables are lined up. We need to see them all lined up in constant. When they are matching opposite coefficients. So either they match or we need to create an opposite. So none of these coefficients, that's our numbers in front, match. So we have to create an opposite. Well, I see an opposite here with a minus and a plus, but then I need to multiply. See what does 3 and 2 have in common? That's 6. So that means I'm multiplying the top by 2. So this would become 8x minus 6y equals 30. And then the bottom, I'm multiplying by 3 to make that 2 a 6. So this becomes 15x plus 6y equals 39. So now I can add them to eliminate the y's. This is 23x equals 69. Is that right? Yeah. And then we're divided by 23. So our x is 3. And then to find the y, we have to plug it back into one of the equations. Doesn't matter. I'm going to just do the first one. So 4 times 3, or 4 parentheses 3 minus 3y equals 15. This is 12. When I subtract the 12, we get a negative 3y equals 3. So our y is a negative 1. So our answer is 3, comma, negative 1. And that will take care of